In the last video, we finished with this method, print itinerary 3, and started looking at the object returned from this call to list.list iterator. I used two methods on this object, the hasNext method to check if there were elements, and the next method to actually retrieve the element from this object. Let's look at this iterator in more detail. Firstly, what exactly is an iterator? In a nutshell, it's another way to traverse lists. So far, we've mainly used for loops to traverse through elements in an array or list. There is the traditional for loop and an index to index into a list, and also the enhanced for loop and a collection to step through the elements one at a time. We've used both quite a few times in the course. Let's look at how the iterator works. If you're familiar with databases, you might be familiar with a database cursor, which is a mechanism that enables traversal over records in a database. An iterator can be thought of as something similar to a database cursor. Specifically, an iterator is an object that allows traversal over records in a collection. The iterator is pretty simple. When you get an instance of an iterator, you can call the next method to get the next element in the list. You can use the hasNext method to check if any elements remain to be processed. In the code, you can see a while loop which uses the iterator's hasNext method to determine if it should continue looping. In the loop, the next method is called and its value assigned to a local variable and the local variable printed out. This prints each element in a list, but does it through or via the iterator object. This slide shows visually how an iterator works using the places to visit list. When an iterator is first created, its cursor position is pointed at a position before the first element. The first call to the next method retrieves the first element and moves the cursor position to be between the first and second elements. Subsequent calls to the next method moves the iterator's position through the list, as shown, until there are no elements left, meaning hasNext equals false. At this point, the iterator or cursor position is below the last element. We looked at this briefly in code in the last video. Let's go back to code now and explore it some more. I'll start with a new method in our main class called testIterator. Private static void testIterator and a parameter of a linked list of strings called list. var iterator equals list.iterator. I'll create a while loop using iterator.hasNext. I'll print iterator.next, and now print out the list. Here I've created an iterator variable, assigning it the result of the list.iterator method. Remember, this will position itself before the first entry in the list. The while loop then checks the iterator.hasNext method, which returns true if there is another item or element available to process. I then print iterator.next, which does two things. First, it returns the next element, and secondly, advances to a position just before the next entry, if there is one. As a result, we traverse through all elements of the list. Lastly, I print the list itself. Back to the main method, I want to comment out the print itinerary 3 method, and now add the call to testIterator, passing it places to visit. Let's see what happens when we run it. I first get my places printed out one by one, and then the full list. One of the benefits of an iterator is that you can use it to modify the list while you're iterating through it. Let's say I wanted to remove all instances of Brisbane from my list and that my list could contain duplicates. I'll add that code to the testIterator method. First, I'll comment out this println. Below that, I'll check if each element is Brisbane, and if it is, I'll use the remove method on iterator to remove it from the underlying list. Is iterator.next equal to Brisbane? Yes, then remove it. Running this now, you can see it worked and Brisbane was removed from this list. But what if I tried to remove Brisbane directly from the list at this point? I'll change iterator.remove to list.remove. Now if I run this, I get a different outcome. In fact, I get a concurrent modification exception. You'd get this same error if you tried to do something similar in an enhanced for loop. The iterator provides a safe way to remove elements while still iterating through the list, so it's important to make sure you're calling remove on the iterator object and not the list object if you want to remove elements like this. I'll revert that last change. Another thing to note is that this type of iterator only allows you to move forward through the elements. This means we can only call the next method on this iterator instance. The only method available for mutating or changing elements in this iterator is the remove method, which we just reviewed. So that was iterator. There is another iterator, the list iterator, that gives us additional functionality. An iterator is forwards only and only supports the remove method. A list iterator allows you to navigate both forwards and backwards. Besides the remove method, it also supports the add and set methods, which function as you probably expect. Let's try out the list iterator. Instead of calling the iterator method, I'll change that to call the list iterator method on list, which gives us a list iterator. Let's try it out. With this one change, I get the exact same results. But now I have that extra functionality. For example, I can change remove to add, adding a new place to visit after Brisbane. Instead of removing Brisbane, this code adds Lake Wivenhoe to my places to visit after Brisbane. It's important to note I'm using the add method on the list iterator and not on the list itself. This code compiles, and if I run it, you can see confirmation that Lake Wivenhoe was added to the list immediately following Brisbane. Now after the while loop, what happens if I want to loop through the elements again? I'll start another while loop, the same as the one above, and print iterator.next. Thinking about where iterator is currently pointing, let's see what happens. I don't get an error, but I don't get any places printed out individually. The line of output at the bottom is from the list printout below the last while loop, and that's because hasNext after that first while loop is false because it's pointing beyond the last element, and as a result the second while loop never executes anything. If I wanted to loop through this iterator again, I can't use this same iterator instance to move forward further, at least not in its current state. And I can't simply reset it to the beginning. I could get a new instance by calling the list iterator method again, or I could move backwards. I'll try moving backwards here, so I'll change hasNext to hasPrevious in the while condition, and I'll print out iterator.previous instead of iterator.next. In this code, I'm actually iterating backwards through the list and printing each town. Will this work? Let's run it to see. It did work. You can see in the output that Toowoomba is printed first all the way through to Alice Springs last, noting that Lake Wivenhoe is still there as well. After running this, the iterator is pointing at the start of the list again, or just before the first element. Another thing I can do is call the list iterator method and pass the cursor position I want to start at. I demonstrated this in the last video, but I'll show it here again. I'll do this creating a new iterator after the last list print statement. var iterator2 equals list.list iterator passing 3 as the argument. Print iterator2.next. This is a way to obtain an iterator with the cursor positioned at some place other than the default, which is just before the first element. Here I've specified position 3, so the cursor is placed between the elements at index 2, Lake Wivenhoe, and index 3, Darwin. Let's run it. I get Darwin printed out. What happens if I change next to previous? I get Lake Wivenhoe. I want to show you one more slide about how iterators position themselves compared to the elements in the list. It's really important to understand that the iterator's cursor positions are between the elements. When the iterator is at position 0 or the start, it's not pointing at element 0. The code on this slide shows an iterator for this list. I get Alice Springs when I first call iterator.next, and that moves the iterator's cursor to cursor position 1, meaning after Alice Springs. Another call to iterator.next returns Brisbane and moves the cursor to cursor position 2, or between Brisbane and Darwin. But if I decide to reverse positions and call previous here, I get Brisbane because the cursor position was 2 when I made this call. Traversing both backwards and forwards through a collection using a list iterator can be a little tricky because of this, but if you remember that the cursor is always between elements, and then with a bit of practice, it will become second nature in no time at all. Okay, so I'll end this introduction to the iterator and list iterator here. In the next video, I'll be giving you a linked list challenge to give you that practice opportunity. I hope I can make that fun and interesting for you. I'll see you in that next video.